Quantum computing sounds like something straight out of a sci-fi movie, right? But here's the crazy part. They are real and are advancing at an increasingly fast pace. Two of the biggest tech giants in the world, Google and Microsoft, are racing to build the future. Google's latest quantum chip, Willow, is making headlines for setting speed records, while Microsoft is quietly developing Majorana 1, their quantum processor, which is a whole new type of qubits that we've never seen before. But there's a real question. One is, who is actually winning the race? And two is, obviously, what the hell does quantum computing even mean? So let's break all this down without the unnecessary tech jargon. It's BTV, let's get to it. Why do we even need quantum computers? Right now, we rely on classical computers. Yes, the one you're watching this video on right now, and even your very expensive $10,000 high-end gaming rig setup. They use bits to process information. Bits are a combination of zeros and ones. Think of it like trying to find the fastest route through a giant maze. A classical computer will check one route at a time, testing the possibility of each route, and then eventually finding the fastest route through a giant maze. Quantum computers, on the other hand, they use qubits, which are a combination of bits which can exist in multiple states of zeros and ones at once, thanks to a phenomenon called superposition. So, in the same case scenario, a quantum computer will check every possible route to that giant maze all at once, concluding at an answer 1,000 or a million times faster than a classical computer would. That means that solutions that would take billions of years for a classical computer would take a quantum computer just minutes to be found. But that's not even the craziest part. Quantum computers use entanglement, which is a bizarre effect that allows the qubits to remain connected to each other no matter how far apart they are. Okay, another scenario. This simply means that they can compare their results. So imagine a math examination where you are asked to compare a given set of values and find their mean, median, mode, and average. This phenomenon can also be found manifesting in sets, a topic in maths also where you are given a universal set, father set, and there are also babies, the subsets, and then you can be asked to find the union or intersection of either the set or the baby sets and the union sets and the likes. Likewise, having two dice, rolling them separately, but somehow they land on the same number every single time. So with the magic of superposition plus entanglement equals computing glory. And that, my friends, is quantum computing. So now the big question is, who is doing the job better? Google or Microsoft? Google's Willow, Microsoft's Majorana 1. Two different companies, two different approaches. Microsoft's Majorana 1 is the secret weapon. Microsoft has been able to develop a new type of qubit, and it's called a topological qubit. So a topological qubit is proven to be more stable and less prone to errors. If you know qubits very well, know that qubits are ridiculously fragile, and any tiny disturbance can throw them off calculation, therefore making them revert back to their classical state as binary or bits. This is termed decoherence. But Microsoft believes that their Majorana 1 chip, built with a new class of materials called superconductors, will solve this problem. And they are not thinking small. Majorana 1 is designed to scale up to 1,000,000 qubits and solve various problems like climate change by helping scientists develop better materials, breaking down microplastics in the environment, advancing AI by making smarter and more efficient algorithms faster. But there's a twist. The problem is it's not available to the public at all. So Microsoft is keeping things behind closed doors. So I guess we'll just have to take their word for it for now. Meanwhile, at Mountain View, California, under the eyes of Julian Kelly, Google is doing a whole different thing. Google's new quantum chip, Willow, is the public powerhouse. I mean, it's already proven results. With 105 qubits, Willow is actually proving something very crucial. Error correction actually works. Normally, as you add more qubits, errors increase, making quantum computing more unstable. But Willow does the exact opposite. It reduces errors exponentially as more qubits are added. This is a game changer. This means quantum computers can finally scale up without becoming unstable. This means a whole lot. How powerful is it? Well, Willow just performed a calculation in under 5 minutes, and that same calculation would take the fastest supercomputer of today 10 septillion years. Yeah, that's actually a real number. Oh, and unlike Microsoft, Google is opening the doors to developers, creating open source software, tools, and even a Coursera course to help people get involved in quantum computing today. So, who is winning? Really, it depends on what you value. Microsoft's Majorana 1 is future focused and secretive, while Google's Willow is here now and publicly available. Yeah, it's showing results and everything. What will quantum computers change? Let's talk about real world usage. Quantum computers, like any other computers of today, weren't just developed to aid faster processing. Obviously, they were set to redefine industries and were made to be used. If successful, quantum computers will assist in medicine and drug discovery. Right now, testing and manufacturing of drugs takes years, but with the aid of quantum computers, they can be able to simulate molecules and reactions at an atomic level, potentially discovering life-saving treatments in minutes. Cryptography and cybersecurity. Today's encryption rely on the fact that certain encryption use math problems that take forever to be solved. But quantum computers, they crack these codes in seconds. That means we'll have stronger encryption cracking and we'll need quantum crackers to crack quantum computerized encryption in the near future. Artificial intelligence. AI is already changing the world, but quantum computer will make it even more smarter. Training AI models takes a lot of computational power. We're talking massive computational power. But with quantum computing, it can be exponentially faster. Climate science and material development. Need a solar panel, need a battery, a way to clean up pollution. Yeah, quantum computing has got you covered. So what then is the verdict? What do we go home with? Right now, Google's Willow is looking to be ahead of the cat race because it's already proven results. But Microsoft's Majorana 1 is more future focused and could be a long-term game changer if their qubit structure actually comes to play. Either way, quantum computing isn't just coming, it is here now. Whether it's in medicine, AI, gaming, quantum computing will change the way we perceive the world in ways we can't even predict it. Now, I want to hear from you. Do you think Microsoft's topological qubit structure would win this long-run race? Or do you think Google's Willow already has the edge because of its error correction? Or do you think this quantum computing is just way ahead of its time? Drop your thoughts in the comment section below. Hey, I'm Brian and I've been making tech videos for almost a year now, and I really put a lot of work into what I do, and I really love making tech stuff. So if you found this deep dive into the future very helpful, you can give this do whatever can support the channel so that YouTube can recommend my content to others. Till next time, stay curious and catch you in the next one.